Hi, and welcome to another Flipped Algebra 2 lesson. Tonight's lesson is systems of linear equations. And our systems are going to contain three equations in three variables. So there is an equation at the board, three equations at the board. Y equals negative 2x plus 14, 3x minus 4z equals 2, and 3x minus y equals 16. To solve this, I have to examine the equations, and the way I like to do it is I like to name the equations 1, 2, and 3. For the purposes of keeping the information organized and be able to go back and look to see if there's mistakes made, it's easiest if we always label our equations as we go. So I noticed that equation number 1 has a y equals. Now y equals negative 2x plus 14 could be used in order to substitute for the variable y into another equation. So solving a system means what is the point, what's the actual coordinate, xyz coordinate, that all three have in common. These are three lines that intersect on the xyz plane. And we want to know what is that exact point. Okay, so a point, if it's a point that is common to all three lines, will work in all three equations. So when you put the equations together, you can actually solve them. So I'm going to take the y equals negative 2x plus 14, and I'm going to notice that I can substitute it in for the y in equation 3. So I'm using equation 3 and plugging in equation 1. Remember, when you plug in, you have to put parentheses so that you remember to distribute any negatives. Okay, now I have 3x minus y, which is negative 2x plus 14, equals 16. Distributing the negative, simplifying the 3x and the 2x, and adding the 14 to the other side gives me 5x equals 30, which then gives me x equals 6. Now I know one of the variables. So I look to see, is there an equation that I can substitute this value in order to solve for one of the other variables? Well, if I put the x into this equation, I can solve for z. If I put the x into this equation, I could solve for y. And if I put the x into this equation, I can also solve for y. So you can pick any of the three at this point and either solve for y first and then solve for z, or z and then for y. And it's up to you at that point. So I'm going to just take equation 1, since it's y equals already, and I'm going to substitute x equals 6 in for the value. Add that together, you get y equals 2. Now I have the value of my second variable. And then last but not least, I'm going to go to equation 2, substitute both my x, or actually just my x, subtract 18, I get negative 16, and divide by negative 4, I get z equals 4. Okay, when you're all finished, we're going to write this in a coordinate x, comma y, comma z format. So the answer is, in order, x is 6, y is 2, and z is 4. And that's our final answer. Okay, in that particular problem, it was a Regents problem, they actually put it into multiple choice and they asked for the value of z. So in this particular one, they were looking for z is 4. The other choices were 5, 2, or 6. So if you notice, 2 and 6 were also choices, and you had to pick choice 4. Okay, I'm going to solve another. So this one largely was by substitution. We're going to do one now where we have to solve it by a method called elimination. You may remember elimination from Algebra 1, where you had two equations and two variables, and you simply added the equations together with the goal being to eliminate one of the variables as you went along. So I'm going to use this next example. The first equation is x plus y minus z equals 6. The second equation is 2x minus 3y plus 2z equals negative 19. And the third equation is negative x plus 4y minus z equals 17. Okay, so upon examination, I'm looking at this and I'm thinking, if I can add equation 1 and 2 together, I could cancel my x's right away. So I'm going to combine equations 1 and 3. So I rewrite 1, I rewrite equation 3, and I'm going to add them together. And when I add them together, my x's will cancel. X minus x leaves me with 0x term. That would be a 5y minus a 2z, and that's going to equal 23. Okay, now, since I didn't actually solve for an equation right there, I am going to label this equation A. I'm going to have to use a different 2 in order to eliminate the same variable. So I have to get rid of the x in a different combination of two equations. I can't use 1 and 3 again. So 1 and 3 have been used. I'm going to look now to see how can I cancel an x easiest. Can I cancel an x easiest with equations 1 and 2? Or can I cancel x easier with equations 2 and 3? And if you're thinking like I'm thinking, 2 and 3 have opposite signs, and we're always going to look for the ones with opposite signs because we're adding them together. So even though this has a 2x, this has a 1x, but the negative presence of the negative x here is going to be more beneficial for the 2x here, because when I add it, all I have to do is manipulate this equation ever so slightly and change it in order to get it a matching or opposite coefficients. So I'm going to take equations 2 and 3. And equation 2 is 2x minus 3y plus 2z equals negative 19. Now equation 3, I wish it had a negative 2x. So we make it have a negative 2x. If I double the entire equation, that will give me the negative 2x that I'm looking for. So I'm going to take 2 multiplied by equation 3. So I'm doubling that entire equation. So it's going to become negative 2x plus 8y minus 2z equals 34. Now the nice thing about that is it's not only going to cancel the x term, but it's also going to cancel the the z term at this point. So I'm going to add these two equations together. The 2x minus the 2x are going to cancel. The 2z minus the 2z are going to cancel. Negative 3y and 8y leaves 5y. If I take a negative 19 and I add it to a 34, I'm going to get 15. And dividing by 5, y equals 3. Okay, now I have a value for y. I have an equation that has a y and a z. So I'm going to use equation A and substitute the value for y in order to solve for the z. So with this, I've got 15 minus 2z equals 23. Subtracting the 15 from both sides, I get negative 2z equals 8. And dividing by negative 2, I get z equals negative 4. Okay, now I've solved for y. I've got z equals negative 4. The only thing left now is to solve for x. So I go back to one of my 3 original equations, and I'm going to plug in the y and the z in order to solve for x. And it looks like the first one is probably the easiest of the 3. We'll squeeze this in here. Equation 1, I'm looking for x. My y is 3. My z is negative 4. So if I'm minusing a negative 4, it's going to become plus 4 equals 6. That gives me 7. If I subtract 7 from both sides, I get x equals negative 1. Okay, so my answer was x, negative 1, comma, y, positive 3, comma, z, negative 4. Now to check, and on the regions you're going to want to check, you're going to want to take these answers and quickly throw them back into one of the other 2 equations and make sure it comes out to be negative 19 for equation 2 and 17 for equation 3. You always want to check to make sure that you've got it right. Okay, there's one more I want to do, and this came up on January 2019 Regents. They're usually part 3 problems, so they're going to be given 4 points, and it's quite a bit of work for 4 points, so it should take a page when you're planning these out. If you're in your notebook, turn the page, and if you're at the bottom of the note page, go to the next page, because it really does take a full page. And the neater you are, the more organized you are with your work, the easier it is going to be able to find mistakes. And it's easy to make them, so you have to go slow, you have to be meticulous, and you have to show all your steps. Okay, so the Regents question was part 3, 4 points, and it said, solve the following system of equations algebraically for all values of a, b, and c. Okay, so the first equation first equation 1 rather, 1 was a plus 4b plus 6c equals 23. I feel like I'm rhyming. The second equation was a plus 2b plus c equals 2. And the third equation, 6b plus 2c equals a plus 14. Okay, notice the form of 1 and 2 are very similar, and the form of equation 3 is a little bit stranger. It's got the b and c on one side and the a on the other with the 14. So the first thing I'm going to do is I'm going to change equation 3 around to put the a on the other side. I'm going to subtract it from 2 sides of the equation. Now notice, when I subtract that from 2 sides of the equation, it's now going to make it nice and convenient to combine equation 3 with 1, get a new equation, and then combine equation 2 with 3 and also get a new equation. So in this one, we're going to first change this around. So the new, I'm going to call it N3, new 3. I'm going to move the a to the other side, negative a plus 6b plus 2c equals 14. Okay, I just moved it to make it convenient. Now, I'm going to combine that with equation 1. So I'm going to write equation 1 right there, and directly under the variables that I'm looking to combine, I'm going to add those 2 together, and what's going to happen to my a's? They're going to cancel. And 6b and 4b give 10b, 2c and 6c give 8c, and 14 and 23 are 37. Now, this equation I will call equation A. Now I'm going to take the new 3 and combine it with equation 2, because remember you have to pick 2 different equations each time you do it. So, new 3, negative A plus 6B plus 2C equals 14 is going to combine now with equation 2, which is A plus 2B plus C equals 2. Okay, we add those together. That cancels. 6B and 2B is 8B. 2C and 1C is 3C. And 14 and 2 is 16. And now I'm going to call this equation B. Okay, now equation A has a B and C variable. Equation B has a B and C variable. So I need to combine equation A with equation B. Unfortunately, the variables have no opposites. They don't match. It looks like I'm going to have to change both the A and the B in order to make an opposite pair. Now, here's the point where you get to make a decision on what you want to do. So let me rewrite A and B at the top. A, 10B plus 8C equals 37. And equation B was 8B plus 3C equals 16. Okay, so I could look at these coefficients and think 80. Multiply this one by 8 the whole way through. Multiply this by negative 10 the whole way through. Or I could look at these two coefficients and think, oh, I could do 24 because that's the least common multiple of both 8 and 3. So I'm going to go with the smaller one, and I'm going to take equation A, and A is going to multiply by 3. So I'm going to write 3A, or 3 times A, and that's going to become 30B plus 24C equals 111. And then I'm going to multiply negative 8 times equation B, and that's going to give me negative 64B minus 24C equals negative 128. Okay, that could be combined. The 24C minus 24C will cancel. The 30B minus the 64B will give me negative 34B. The 111 minus the negative 128 will give me negative 17. And if I divide both sides by negative 34, I get B equals 1/2. Okay, so I have one variable. All that work for just one variable, and I'm out of room. So I'm going to erase, I have to keep one of these equations. I'll have to keep this equation B because I'm going to use it to solve for C in a second. So everything above it I'm going to erase, leaving my original 2 equations, because 3 equations, because I need to see them. Okay, so I'm going to use now equation B, and I'm using it to solve for C. So 8B plus 3C equals 16. B is 1/2. Substituting in the 1/2, half of 8 is 4. If I subtract 4 from the other side, I get 3C equals 12. And then if I divide by 3, I get C equals 4. Okay, that's done. So now I got B, I got C, and the only thing left now is to find A. So again, I'm out of room. I'm going to just erase this work and make the substitution to solve for A. Okay, so you could use any one of them. It doesn't really matter. I'm just going to use the top one. So I'm going to go back to equation 1. A is what I'm looking for. B was found to be 1/2. And C is 4. And that whole thing, wait, did I mix up? I did, right? C is 6C. 6 and C is 4. And that equals 23. Okay, so A plus 4 times B plus 6 times C equals 23. A is my only variable. Half of 4 is 2. 6 times 4, 24. 24 and 2 is 26. And if I subtract 26 from 23, on both sides I get -3. Okay, so my answer here complete is A, -3, B was 1/2, and C is 4. So an example where you actually get a fraction for one of your variables, and knowing how much you guys love fractions, that is definitely a problem that we want to review and do again. Okay, so that's all for tonight. That's solving systems of linear equations. 3 equations and 3 variables. First by the substitution method, and secondly by the elimination method. Okay, hope you enjoyed the video. Please like, share, and subscribe to Algebronx. All right, see you soon. Bye.